We are MARS Aerospace Company, and our mission is to preserve the space environment and produce highly affordable spacecraft. And that mission begins here on Earth. It starts in our manufacturing facility in Alachua, Florida. Here we have a variety of CNC machines, traditional manufacturing equipment, and 3D printers. This allows us to produce a majority of our components in-house, saving us time and money when manufacturing products and prototypes. Additionally, by having this equipment available to us, we're able to perform manufacturing services for other companies both in and out of the space industry. We currently have 3 products under development, the first of which is a 1U CubeSat. This is a 1U sized observational satellite designed to be operated in low Earth orbit. This satellite uses consumer-grade, affordable electronics to record and transmit data through its transceiver. The data received from this can be sold or directly utilized by MARS Aerospace Company.
This is a physical prototype of our 1U CubeSat. So this is what we call the DevSat, and as you can see, we've got a Raspberry Pi in here, as well as a solid-state drive reader, a power control board, and a battery. And so essentially, you just flip this thing on, and you're able to plug it into a computer and test software, as well as video output from it. And essentially what this is a prototype for us to be able to, like I said, test the software, as well as the hardware integration into this volume.
Another vehicle currently under development is an approximately 30 kilogram satellite called Badger, designed for orbital debris removal and satellite life extension. It utilizes AI software developed in collaboration with the University of Florida to autonomously dock and rendezvous with objects of interest. This vehicle is also designed to be highly modular and mass producible. Space for additional payloads and sensors can be seen around the outside of the internally mounted propellant tank. Unlike the 1U, this vehicle has an onboard propulsion system. It uses highly pressurized supercooled nitrogen gas as the main propellant source. Our third and most ambitious project is the Raven spacecraft, which is an Espa Grande class vehicle designed to carry cargo to orbit and perform a variety of in-space servicing, assembly, and manufacturing tasks. The vision of our company is that these 3 satellite platforms can be used to perform a variety of tasks required to build the in-space manufacturing economy. Once the Badger and Raven are both completed, this is what a typical ConOps might look like. The Raven will take up a payload, whether a Badger or another paying customer, and then the Badger will have the ability to either autonomously rendezvous with debris or another satellite to extend its life.
All right, so this is our Raven prototype test frame. So what we've got is a compressed nitrogen cylinder hooked up to the pressure control regulators for the macro thruster, as well as the 4 reaction control thruster blocks that we have as well. So all these nozzles here are 3D printed, and then all these lines are the solenoid valves on them are controlled by this relay board here in the center, and then the commands to activate that are sent here from this laptop. So we're going to go ahead and do a demonstration of some of the reaction control valves as well as the main macro thruster. So as you can see, I just tested all the reaction control valves, so those are able to activate and fire. And then we're going to do a dump on the main macro thruster here in the center. So that's set to 30 PSI just for a test, but we can crank it up as well with the pressure regulators and do another test at 60. So as you can see, the purpose of this is really just for us to test these different pressures going through these nozzles and be able to test this as a fully integrated system within the actual payload volume expected for the Raven spacecraft. So that's what this frame is based on. This is an aluminum version of that. And yeah, this is the Raven Espa Grande class spacecraft prototype.
All we need is additional funding through either investors or contract funding in order to pay for the continued development and launch of our vehicles. Once that's complete, MARS Aerospace Company will be able to provide debris removal services and help clean up the space environment. We will also become part of an entirely new frontier of the space domain, Space 2.0, when manufacturing happens in space. We're the right team here at the right time, and we'll stop at nothing to achieve our mission.